All right, friends, welcome back. We're going to go over order of operations now. I'm going to write that nice and big for us. Order, oops, I can misspell order of operations. That's crazy, isn't it? Order of operations. So our main operations are multiplication, division, addition, subtraction. And then as well we have exponents, which is just multiplication. Um, and then we'll go into our grouping. So order of operations, there we go. So if that's PEMDAS, please excuse my dear Aunt Sally is maybe something you've heard before. I'll write that out. So another mnemonic where the first letter stands for the steps, kind of like the Does McDonald's sell burgers raw I was showing us. So please excuse. My dear Aunt Sally. So this is a fun word for me, aunt, because I'm from Indiana. We say aunt there. My mom's from Virginia, actually, so they say aunt. I'm curious to know how y'all pronounce this word, because I know some people feel very strongly about how it's pronounced. So please excuse my dear Aunt Sally. That's parentheses, exponents, multiplication, division, addition, subtraction. And I showed you guys I like to write PEMDAS like this. To remind myself as well as students that we do anything in parentheses first, any exponents we see, and then multiplication and division, whatever shows up first in order from left to right, just like how we read a book. So this is left to right. And that's the same thing with addition and subtraction. So after we've done everything in the parentheses, anything with exponents, any multiplication division in order from left to right, we'll do any addition subtraction in order from left to right. Now I wanted to take a moment to talk about another acronym that we use. So there's PEMDAS, here's this acronym. There's also a new one being taught called GEMMA. I don't know if this would, yeah, I'm actually going to write this out real quick just to show you guys a little visual aid. GEMMA goes over the exact same information. Um, it's just a, sorry, I'm so mad at that addition sign. There we go. Okay. It goes over the same information, it's just worded a little bit differently, and that might make it a little bit more clear for you. So the G in GEMMA stands for grouping, and that's because we might not only interact with parentheses, we could also interact with square brackets, and I'll even include some examples of that just so we can really see. So grouping can be parentheses or it can be square brackets like these, which will often have parentheses inside of them. That's like if there's a really crazy expression that we're working with, which I promise we won't in this class, but for the sake of telling you about this and showing you all of the correct information, I want to incorporate this. And then exponents, which again, just to kind of have a little space for exponents here. Exponents are just multiplication. So x is going to be my base number, my base, and then whatever my exponent is, I'll put it as an e. That's my exponent. That tells me how many times I multiply my base number together. I don't know if I really need to write exponent again, but exponent, yes, I'm writing that correctly. So as an example, if I have 4 to the 5th power, I have a base of 4 and an exponent of 5, I'm going to multiply 5 4s. There's 1 4, there's a second 4, there's a third 4, there's a fourth 4, and then this is my 5th and final 4. If I have 2 cubed, or 2 to the 3rd power, I would multiply 3 2s. There's my first 2, there's my second 2, there's my third 2. There we go. If I had 7 squared, or 7 to the second power. I would multiply two sevens. There's my first 7. There's my second 7. So that's just a little rundown about exponents again. It's just multiplication. My exponent tells me how many times I multiply my base number together. So 2 times 2, that's 4, times another 2, this is going to be 8. So I should get 8 if I'm going to solve 2 to the third power or 2 cubed. It's not going to be addition. I shouldn't get 6 out of this. 2 cubed is not equal to 6. I'll even put that down just for the sake of writing it. 2 cubed, or 2 to the third power, is not 6. It is not addition. I see people get confused about that a lot. It's not addition. I do not want to see you adding when there's exponents in my class. I will firmly and gently tell you that we are not adding, we're going to be multiplying. So no worries if you forget, I'm here to remind you. So E, that stands for exponent. I'm going to try and do something here. I'm becoming a professional at this, y'all. Oh, that's not what I wanted one bit. Can I just move this? Okay. I'm just going to erase it and rewrite it next to it. I'm not a professional, guys. I lied to you. I'm very sorry. Alright, so this is exponents. I'm a big fan of Gemma because I think it takes out some of the confusion of PEMDAS. So there's x to the e, my exponent. And then M stands for multiplicative. It does not stand for multiplication, it stands for multiplicative because there's a multiplicative relationship with multiplication and division. They're opposites of each other, right? So let me write this out. Multiplicative. So that's both multiplication and division. Again, whatever order they show up in and left to right, just like how we read a book. And then there's additive, which is the additive relationship between addition and subtraction, because they're opposites of each other as well. They're opposite operations. So it's addition, subtraction. Again, whatever order they show up in first, left to right. Okay, now that I've taken like 8 minutes to go over all of this, I want to be very clear about it. Let's go ahead and jump into an example. So let me box this off. I like to create boxes. I don't know if you guys have noticed. I hate that box though. Those lines were terrible. Okay. I'm figuring it out, y'all. Maybe by the end of the class, I'll actually have this all down. Okay, there we go. So let's do an example. Let's see. I'm just making these up off the top of my head. I have no idea how this is going to turn out, so we'll find out together. I'm going to do one without any square brackets first, so we won't worry about these. I'll just use parentheses, exponents, multiplication, division, addition, and subtraction. So let's do 2. I'm actually going to write this up a little bit higher so I have a lot of space. 2, and then I'm going to group. I'm going to use the entire quantity of whatever's in my parentheses. I want 3 to the 4th power minus 7 plus 8. I'm going to close my parentheses, and then I want to add 9, why not, and divide by 4. I hope we don't get too crazy of an answer from this, but let me check. I have parentheses in here, I've got an exponent, there's multiplication and division, and there is addition and subtraction in here. Okay, so the thing with the order of operations that I kind of dislike, makes it maybe a little bit difficult to teach and for people to understand, is that inside of the parentheses, the order of operations kind of starts over. So inside of my parentheses here, I have to think, okay, I have to find my exponents. I have to do any multiplication, division in order from left to right. Then I have to do addition, subtraction in order from left to right. And that can be kind of difficult when you're first learning order of operations, right? And you have to, kind of do parentheses, do it all in here, and then you have to do the order of operations for the rest of your expression outside of the parentheses. So let's go ahead and see this. I'm going to ignore everything outside of the parentheses and just do what's in my parentheses for now. So I look at my parentheses and I see, oh, I have an exponent here. That comes before anything else in my order of operations, so I'm going to do that first. So I'm going to do that up here. I have 3 to the 4th power. So that's going to be 3 multiplied by itself 4 times. So that's 1, 2, 3, 4 3's multiplied together. So 3 times 3, that's going to get me 9. 9 times 3, that's going to get me 27. Oh, that's kind of a cool 2, y'all. This is how I normally write my 2, so that's like a fancy 2, isn't it? Anyways, 27 times 3, let's see, let's do that off to the side over here. 3 times 7 is 21, 3 times 2 is 6, plus 2 is 81, so 3 times 27 is 81. So 3 to the 4th power is equal to 81. So I'm going to put 81 in here. Then I'm going to rewrite the rest of my expression. Now I have 81 minus 7 plus 8, close my parentheses, plus 9 divided by 4. This is how I'm expecting you to write your work. I want everything to be written nice and neat, and we're going to work down vertically. This is algebraic way of doing math, and I find it to be the most organized way to do math. And the reason why I'm advocating for this is because as your teacher, when I go in and grade your homework, I'm going to be looking at your work. Your work is part of the grade. It allows me to see what's going on in your brain, how you're working the math out, and if you got the wrong answer, I can look back at your work and I can pinpoint, oh, this is where, a mistake was made and the rest of the work isn't correct because of this mistake. Or I can say, oh, they used the wrong method. I need to reteach them this because maybe they didn't understand the first time I taught it. But as well, you should be checking your own work too. So you can look back, you can double check, make sure you didn't write a number wrong. Like yesterday in math when I accidentally carried over a 1 instead of a 2, and that made my math wrong, and Jordan's math was correct, and I made him think he was wrong the entire time. Sorry, Jordan. So yeah, please make sure that you're writing all your work out very clearly like this. So let's go ahead and continue. So I have 2, then I'm going to work in my parentheses still because I haven't dissolved them, they're still here. And I'm going to look and say, okay, there's no multiplication division in here. There is addition subtraction though, so I'm going to do it in order from left to right. So I have 81 minus 7, just for the sake of doing it. Let's just do it off to the side over here. 80, whoa, that's a kind of a, let's keep it in red, I guess. That's, the green one's kind of a big pen. 81 minus 7, a little subtraction review. So I'm going to work, let's use the highlighter, vertically with my ones place first. I have 1 minus 7. Oh, can't do that, so I'm going to have to borrow. So I go over to the place value to the left. That's my 8. I'm going to take 10 away from my 8 because it's 80, right? I'm taking 10 away from it. I'm going to make it a 7. Now it's 70. And I'm going to move that 10 over here to the 1 and turn this into 11. Notice how I made my 1-digit number a 2-digit number now because I borrowed from the next place value over. So now I have, there we go, 11 minus 7, which is 4. And then I have 7 minus nothing, which is just going to be 7. So 81 minus 7 gets me to 74. So I'm going to write 74 plus 8, close my parentheses, plus 9, divided by 4. And now I keep on going. I have 2, parenthesis, 74 plus 8. Let's do it off to the side, why not? A little addition review. 74 plus 8. So 8 plus 4, or 4 plus 8, remember it's commutative property. I tend to move up when I do addition and I say 8 plus 4. You can move down because it is written, top down. That's how we read a book, right? So you could say 4 plus 8. You'll get the same answer as me. So that is 12. So I put my number in the ones place, which is the 2, underneath my 4 and 8 in the same column. And I'm going to carry over my 1. This is the opposite of borrowing, remember? I'm going to carry over my 1 to the next place value over. And now I have 7 plus 1, which is 8. So 74 plus 8 gets me to 82. So I put 82 inside my parenthesis. I don't have any other operations, so I can close my parenthesis. And then I put the rest of my expression, plus 9 divided by 4. So I mentioned this in class yesterday. There's a few ways we can see multiplication be written out. We can see, I'll use just 7 times 2 for all these examples. We can see it as the typical x that we saw in school. We see that I like to use the dot, 7 times 2. Some people use an asterisk or a star. You might see that as well written online. That's how a lot of people will represent multiplication. You can also see it as parentheses, so 7 inside parentheses, 2 inside parentheses. That's multiplication. 7 outside the parentheses, 2 inside the parentheses. That's multiplication. So there's quite a few ways that we can write multiplication, and it's good to be familiar with all of them. Give me just a moment, I'm going to drink some water. All right, so with that out of the way now, I'm going to look at the rest of my expression. I don't have anything else going on inside my parentheses, so I can finally move on. So I look, do I have any exponents? Oh, I don't have any exponents. So I look, do I have anything multiplicative? Do I have any multiplication or division? Oh yeah, look, I have 2 times 82 right here. Let's go ahead and do that off to the side. 2 times 82. I'm going to put my bigger number on top, and then I'm going to put my 2 and line it up in the ones place value. So 2 times 82. Let's do this together. I'm going to start in the ones place, 2 times 2, which is 4, and then I'm going to move diagonally. Let's do this color. 2 times 8. 2 times 8 is 16. I don't have anything to carry the 1 from my tens place over from the 16 to, so I'm just going to write 16 down here. 82 times 2 is 164. So now I'm going to write that. 164 plus 9 divided by 4. That's supposed to be division there. There we go. So now I look, do I still have anything multiplicative, multiplication or division? Addition, oh, I have division right here, 9 divided by 4. So now let's go ahead and do that. 9 divided by 4. So remember from the last video I just did on long division, we have our dividend here and our divisor here. Our dividend goes inside of the bracket, so 9 goes inside, and 4 is going to go on the outside. I can already tell you right now we are going to have a remainder, a decimal remainder. I do apologize since I did just make this up on the spot. It's not going to be a whole number answer, but I like that because it's good to challenge ourselves and to get comfortable working with decimals, because that is going to be something coming up very quickly for us. So anyways, let's go ahead and review. Does McDonald's sell burgers raw? My first step is division. How many times does 4 fit in 9? Let's see, 4 would fit in 9 at least one time. 4 times 1 is 4, and 4 is less than 9. Let's see if it fits in any more. 4 times 2, that's 8. 8 is less than 9, so I can fit 2 4s in 9 for sure. What about 3 4s? 4 times 3 is 12, which is larger than 9. So I can't fit 3 4s, but I can fit 2 4s inside of 9. So I'll put a 2 up here. Now I multiply. 2 times 4 is 8. I can subtract. 9 minus 8 is 1. And I don't have anything to bring down, but remember I prefer decimals instead of just remainder. So we're going to create a decimal place in our dividend. And I'm actually going to erase this really quick, get it out of the way because I need space for my dividend there. There we go. So now I can take my decimal point, put it up in my quotient. I just send it straight up, and now I'll bring down my 0. And now I repeat. How many times does 4 fit in 10? Well, we know 4 times 3 is 12, which is larger than 10. So I can still only fit 2 4s inside of 10. So I put my 2 up here above my 0 I just made. And now I go to my second step. I multiply. 2 times 4 is 8. I subtract. 10 minus 8 is 2. And I still have a remainder, so I'm going to put another 0 in my decimals place. And I will bring that down and repeat. How many times does 4 fit in 20? Well, let's together. 4, 8, 12, 16, 20. 4 will fit into 25 times perfectly. So I put my 5 above my 0, and just so you can see too how I did that, I just skip counted on my fingers, but you can also write it on paper. 4, 8, 12, 16, 20. That's 1, 2, 3, 4, 5 fours fit inside of 20. So 5 times 4, we know the answer to that. It's 20. I just wrote it right over here for us. So there's 20. I subtract and get 0, so I don't have any remainder left. So 9 divided by 4 is 2.25. So let's go back over here and write that down. I have 164 plus 2.25. And now I can go to my final step of PEMDAS or GEMMA. I'm going to look for any additive relationships, addition or subtraction, in the order they come in left to right. So I look, well, I only have one operation in here, and that's addition. So that's what I'm going to do. I'm going to do 164 plus 2.25. So I'm going to take my 164, and what I'm going to do is kind of like what I do with division here. I'm going to create a decimal point. I'm just going to put some zeros in there. So I count, I have 1, 2 decimal points there. So I'm going to put 2 zeros here. And now I'm going to line up at my decimal point here. So that's 2, line up my decimal, 0.25. And I can add. 0 plus 5, it's just 5, identity property. 0 plus 2, 2. 4 plus 2 is 6. 6 plus nothing, 6. 1 plus nothing, 1. So my final answer for this is 166.25. One of the other things I'm expecting is I want you to box or circle your answer when you're done, so that I can very clearly see that your answer is there. So I have all this wonderful work I can look at on your homework. I can see exactly the process you went through, and then I can look and say, okay, here's the answer, and I can see if it's correct or not. So I know that was a lot. Let's go ahead and type this into Desmos. And we have to be very careful, because a lot of scientific calculators, online at least, when they do division, they actually make it into a fraction. So we have to be very careful about how we type things in. So let's go ahead and go over here to Desmos. It'll take a moment to load. There we go. So I have 2, and then inside my parentheses, let's look. I should probably write this on a piece of paper so I don't have to go back and forth a bunch and wait for things to load. Give me just a moment. 2, okay, let's go back to Desmos now that I don't have to flip back and forth. So I had 3 to the 4th power, oops, I closed my parenthesis early, minus 7 plus 8, now I close my parenthesis, plus 9 divided by 4. Notice how it turned it into a fraction. So if I had more going on, let's say my problem was all of this and then I multiplied by 5 at the end, I'd have to make sure I leave the division like this and that I actually go and multiply my 5 there at the end. But that's not what we're doing. So look, we have 166.25. 166.25 here is our answer. So let's see. Let's go ahead and do another example. Let me lasso all of this and oops. I'm going to erase things I don't actually want to erase. Oh, it did the entire, that's not what I want. I just minimize. Oh, this is amazing. Okay, y'all, I'm figuring this out. All right, let me go erase a few things, and then we'll move on to a second example, and then we will call this done. Okay, let me rewrite. I just noticed that some of my numbers were taken here. So 2, 4, 3, there's second 2. There we go. Okay. So let's come up with another example. Let's see. Let's I'm gonna work on this side just because there's a little bit more room over here. And we'll review this example as well in Desmos again, just so we can kind of see. I'm gonna make this one a little bit more complicated so that when we type it in Desmos, I can talk a little bit more about how you have to type in things very carefully. Just notice there's no O and not no. There we go. Okay, let's do 4. I'm going to use a square bracket. 4 times 3, then a parenthesis. Let's do 9 squared divided by, let's see, 9 squared divided by 2, why not? I think we're going to get a decimal again for our answer, but that's okay. Minus, let's see, let's do 30 times 7, and we'll close our square bracket. Let's make more. Let's do, we haven't had addition yet. Let's add addition in here. We'll add 21. I'm just doing random numbers right now. And let's multiply 4. And let's subtract some more. Let's do 10. No, I'm going to do 15 actually. I changed my mind for some reason. Minus 15 plus, let's do another exponent. Let's do 10 to the second power, 10 squared. Okay, this is pretty long, right? We have 4 times the entire quantity of 3, and then we have that multiplied by 9 squared divided by 2, and then we're also subtracting 30 and multiplying 7. And then to all of that, we are adding 21, multiplying 4, subtracting 15, and adding 10 squared. Whoa, y'all. Okay, so let's take a look at this. So here we have our grouping. We're going to focus solely on what's inside of my brackets. But you'll notice we have a second grouping inside of here. So we'll actually focus on this first, and then we'll focus on the rest of what's in our brackets, and then we'll be able to move on to what's outside of the brackets. So we're going to keep our 4 and our square bracket and our 3, and then we're going to do what's inside the parentheses. Add 9 squared. That's 9 times 9. You guys remember that 9's trick I showed you on your fingers? Go ahead and try that now. You should get 81. 81. I should have warned you to pause. That's my bad. Anyways, 81 divided by 2. Probably should have made that 3 in hindsight. Anyways, close parentheses, minus 30 times 7, close my square brackets, plus 21, multiplied by 4, subtract 15, and I will add 10 squared. Okay, I need to drink some more water, y'all. I've been yapping, haven't I? This is already almost 30 minutes long, my goodness. This will be our last example, and then I'm calling it quits. So now, we still have our parentheses to do before we can move on to the rest of what's inside our square brackets here. So, I'm going to write my 4, keep my square bracket, then I have 3, then inside my parentheses I have 81 divided by 2. So let's do that off to the side over here. 81 is my dividend. It goes inside of my long division bracket. 2 is my divisor. It goes on the outside. And again, this is going to have a remainder, so we will have to do a decimal point. So first step, divide. How many times does 2 fit in 8? Well, it fits in there 4 times. 4 times 2 is 8. I subtract. 8 minus 8 is 0. I bring down my 1, and I repeat. How many times does 2 fit in 1? Well, 2 can't fit in 1. 1 is less than 2, so it fits in there 0 times. 0 times 2 is 0. I subtract. 1 minus 0, identity property, is 1. And I have a remainder. So I'm going to create a decimal point in my dividend, and I carry my decimal straight up to my quotient. And now I can bring down my 0 that I just added on, and I repeat. How many times does 2 fit in 10? Fits in there 5 times. 5 times 2 is 10. I subtract and get 0. Oops, I'm sorry, I'm running out of space here. There's my 0. And there's no remainder. So my quotient is 40.5. So I can write 40.5 inside of my parentheses now. 40.5, and then I subtract 30. Oh, that is a very straight parenthesis. There we go. Minus 30. Multiply by 7. I can close my square bracket. And now I can add 21. Multiply 4. Subtract 15. And add, I just noticed that 10 squared up there looks like 102. Let me make that a little bit more clear. 10 squared, there we go. Now I add my 10 squared down here. I'll make that very clear. There we go, not 102, 10 squared. All right, so I know my decimal point here kind of looks very similar to my multiplication points. Usually I make these more prominent when I'm writing, like on the whiteboard or on paper. But with the mouse it's been a little bit difficult, so please forgive me. And again, just to make these really prominent, I'll go back through. There we go. Okay. So now let's look. I did everything inside this parenthesis. Now it's just a single digit number. So I've kind of, in a way, dissolved that parenthesis. So I can move on to the rest of my square bracket here. So I'm going to write 4, my square bracket. So now let's look. I don't have any more exponents in here. I don't have a parenthesis to deal with. So I'm going to look for anything multiplicative. So I look, oh, right here, 3 times 40.5. So let's go ahead and do that. 40.5. And I'm going to line my 3 up. I know I've been telling you the ones place. We're actually just going to do the rightmost place value. So I'm going to line my 3 up with my tenths place. I don't know if you're going to hear that very well. I know this microphone is like not the best audio quality. So let me drink some water really quick again. I'm tiring my vocal cords out right now. And let's keep trucking on forward. We're getting there, y'all. Thank you for sticking with me. So we have 3 times 5, that's 15. I'm going to carry over my 1 to the next place value. 3 times 0 is 0, plus 1 is 1. 3 times 4 is 12. There's no other numbers for me to carry anything over to, so I just write my 12 straight down here. Now, when you multiply a decimal number by a whole number, you just have to drop your decimal straight down. So I leave my tenths place, and then I have my ones, tens, and hundreds place left alone over here on the left. So this only is true, and we'll get into this more when we go over decimals, but this is only true when you multiply a decimal by a whole number. That's when you can drop your decimal point straight down and keep your decimal point right here. Do you see how it reconnected for me? All right, so 40.5 times 3 is 121.5. So I'm going to write that, 121.5, and then I write the rest of this, whoops, minus 30 times 7, I'll make that really prominent, times 7. I close my square brackets, I can add 21, multiply by 4, subtract 15, and add 10 squared. Okay, y'all, we are getting there. So now I'm still in my brackets because there's still operations happening in here. I haven't quite dissolved them yet. So I look, is there anything else multiplicative, multiplication or division? Nope, so I'm going to look for anything additive, addition or subtraction. Well, there's only one thing going on here, and that's subtraction. So we have 120, oh, I apologize, y'all. There is multiplication happening here. That is completely my bad. So we have 30 times 7 happening over here. So we still have multiplicative before we move to our additive. I have 30 times 7. I'd get a very different answer if I started subtracting this and then I multiplied. We want to make sure we do any multiplication division before we move on to any addition subtraction. Remember, in order from left to right, whatever comes first, just like when we read a book. So I have 30 times 7. 7 times 0 is 0. Hold on, my lights just shut off in my office. There we go, I had to reactivate them, I've been too still. 7 times 3 is 21. I don't have anything to carry my 2 over to, so I write it down here. 30 times 7 is 210. So now I can write, oh, I can change my colors. Okay, cool. For my square bracket, 121.5. Oh, we're gonna have a negative number here. I'm sorry, y'all. 121.5 minus 210. Close my square bracket, add 21, multiply by 4, subtract 15, and add 10 squared. I'm gonna have to zoom out a little bit so I can make more space. I chose I'm gonna zoom in one more actually. It's too zoomed out. I told you this was gonna be a difficult one, and I did that on purpose. But I'm accidentally showing us some things that aren't necessarily part of the class, but it's still really good to know. So let's see, I'm going to make a little line here. This is where I'm gonna go into our negatives really quick. If you're really curious about working with negative numbers, I can help you with that. I can also make some resources for you to look at for that as well. We won't get into it in this class, and I don't expect that, well, we will actually when we talk about temperature, because obviously negative temperatures, but I don't expect that you would actually really need to use negatives in your field. But they're still kind of a fun, logical way to think about numbers, and it can help your problem-solving skills, which is why we talked about math being so important. We have calculators, as long as you know how to properly use a calculator, which it's my goal to teach you how to properly use a calculator. You can, do all the math on there, but it's good to exercise our brains because it helps us be better thinkers, helps us be better problem solvers. So yeah, anyways, negatives. So we have 121.5 minus 210. Okay. I'm making this video a lot longer than maybe it needs to be. So I have 121.5 minus 210. There is okay. So subtraction and negative numbers are very closely related because I can rewrite this problem as 121.5 plus negative 210. This is what subtraction problems really are. Like if I have 4 minus 3, I'm really taking 4 and adding a negative 3 to it. So 4 minus 3 equals 1, 4 plus a negative 3 still equal to 1. I'm taking 3 away in both these instances. They're just written differently. And the reason why it's important for me to write it this way is because my negative number, it's less than 121.5, right? Because if I have a number line here, here's my 0. To the right is positive numbers, to the left is negative numbers. As I move to the left, my numbers get smaller in value, so negative 210 is less than 121.5. But if I look at this part right here, it's bigger than 121.5, right? And that makes my math a little bit more tricky. So what I can do is I can use the commutative property of addition. I can do negative 210 plus 121.5. And now there's a few ways we can think about this. I'm going to show you how I think of, well, I'll show you how I think about it second actually, because it might take a moment to wrap your mind around it. So you can think of it as negative 210 plus 125. Oh, sorry, 121.5, not 125. There we go. And you can say, how much would I need? Well, okay, I'm actually sorry. I'm going to back up a lot. I'm just going to show you the way I think about it. what I'm going to do is I want to find out the difference between 210 and 121.5. And because I've been doing a lot of math, and I've been teaching math, I know that because man, y'all are making this so difficult for you guys, I'm sorry. I'm just gonna tell you the truth of this, and if you want the explanation for it, you can come see me. I'm not gonna try and make this video longer than it needs to be. I'm gonna do 210 minus 121.5. I have to create my decimal point up here for the 210. And I know my answer is going to stay negative because 210 has a larger value than 121.5. So because this has a larger value, I'm going to keep the negative sign on my answer. So now let's take a look at it. I have 0 minus 5. I'm going to have to borrow. Can't borrow from 0, so I have to borrow from the 1. And before I can carry over to here, I have to actually make a pit stop here and make this a 10. And then borrow from my 10, make this a 9, and make this a 10 finally. I have to kind of make a pit stop there. So I have 10 minus 5 is 5. I bring down my decimal point straight down. Now I have 9 minus 1, which is 8. 0 minus 2, I can't do that, so I'll have to borrow again. Turn my 2 into a 1, make this into a 10. 10 minus 2 is 8. So I have negative 88.5 is my answer to this right here, 121.5 minus 210. So now I can write for my square bracket, negative 88.5, oops, I almost wrote a parenthesis right there, plus 21 times 4 minus 15 plus 10 squared. Okay, so now I have done every operation that is in my square bracket. And this is just another way to represent multiplication. So I told you, we could have parentheses like this. We could also see a square bracket like this. It's much more rare to see this unless you're doing a problem like this where there's like a ton of stuff going on, which I promise we will not have anything like that on the final. I'm showing you problems that are more difficult than what you're going to be tested on so that the things you're tested on seem easy to you, right? I want to build your confidence a little bit. But as well, I just like math and I like to show people things that traditionally may seem challenging about math. So now I have 4 times a negative 88.5. So now I get to work with that. So I'm just going to tell you a positive number times a negative number is going to give us a negative answer still. For the sake of getting rid of our negative, I'm going to retcon this a little bit. I'm going to make this a negative 4. I hope you don't mind me changing that. If this second problem is confusing for you, please just like stop here and ignore all of this and go back to that first example if that made sense. I probably should have come up with some problems and checked them first before recording this, but I'm almost 45 minutes in, so no going back now. So a negative number times a negative number gets us a positive number. So I'm going to try and get rid of this negative now. No more negatives. So let's do 88.5 times 4. We'll just leave it at that. We'll leave the negatives off because I already know my answer is going to be positive. So 88.5 times 4. Again, we're doing a decimal times a whole number, so I have to make sure I drop my decimal down into the product of this. So I have 4 times 5 is 20. I carry my 2 over to the next decimal, or sorry, to the next place value. 4 times 8 is 32, plus 2 is 34. Write my 4 down, and my 3 up here. Again, 4 times 8 is 32, plus 3 is 35. I don't have anything else to carry over to, so I just write my 35 down here. And I drop my my decimal point down into the same place value. So I still create a tenths place. And lucky us, we actually got a whole number, so now we don't have any more decimal value. Thank goodness. So now I did negative 4 times negative 88.5. I got positive 354. I don't have to write my 0. So I do 354 plus 21 times 4 minus 15 plus 10 squared. There we go. Whew, oh my goodness, y'all. Now we just have like a normal expression we still have to do PEMDAS or GEMMA through, whichever you prefer again. So let's go ahead and take a look through it. I did all of my grouping. I don't see any more parentheses or square brackets, so I go to my next part, exponents. Let's look, Oh, here I have an exponent. I'm gonna highlight it just for the fun of highlighting it. Let's use green. Oh, green's my favorite color, y'all. Anyways, I have 10 squared. So remember with exponents, it's showing me, I'm gonna do it over here, how many times I'm multiplying my base number. My base number is 10. I'm going to multiply it twice. There's one 10. Here's my second 10. 10 times 10 is 100. I'll show you my hanging zero trick again. So I'm going to write my first 10 up here. And my second 10, I'm going to shift it over to the right one place value. So I'm going to write my 1 from the tens place under my ones place. And I'm going to hang my zero, quote unquote, off the end. So I can drop my 0 down immediately, and I just multiply my 1. 1 times 0 is 0. 1 times 1 is 1. There's my 100. Hold on, that 0 had like a little line that looked like a 1 as well. It looked like 1,100 for a moment. There we go, 100. So now let's rewrite this. I have 354 plus 21 times 4 minus 15 plus 100. Okay, so let's check. I did all of my exponents. Yes, I can move on to anything multiplicative, any multiplication or division left to right in the order it shows up. So I look, bam, bam, bam. Oh, here it is. I have some multiplication. Let's highlight it. I have 21 times 4 right here. So that's what I'm going to do. 21 times 4. 21 times 4. 4 times 1 is 4. 4 times 2 is 8. 21 times 4, we get a product of 84. That was pretty easy, thank goodness. We're getting to the end, I promise y'all. I'm gonna do a little, there we go, scroll down a little bit. I can't scroll with my actual mouse wheel. I'm gonna have to mess around with this a lot more. So I rewrite 354 plus 84. Oops, there we go, plus 84. My product, my solution to this multiplication problem we had, minus 15 plus 100. Sorry, y'all. Oh my goodness. There we go. So now let's look. Did I do everything multiplicative? Did I do all multiplication, division in order from left to right? Yep, I don't see any more of those operators. Now I do anything additive, addition or subtraction in order from left to right. So let's look. Okay, here's my first thing. I have 354 plus 84. So let's do that. I have 354 plus 84. 4 plus 4 is 8. 8 plus 5 is 13. I write my ones place my 3 in the same column. I carry my tens place the 1 over to the next place value. 3 plus 1 is 4. So I got 438. 354 plus 84 is 438 minus 15 plus 100. Now I keep going in order. So I have 438 minus 15 now that I'll be doing. So 400, oops, want red for that. 438. Sorry, that's a crazy 4. 438 minus 15. I can do 8 minus 5 is 3. 3 minus 1 is 2. 4 minus nothing is just that 4. So I got 423 for that portion. So I write that down, 423 plus 100. And look, y'all, I'm into my last operation now before we get our final answer. We are almost done with this example. So for the sake of just being clear and doing this so we can all see the work that I'm doing, I'm going to set this up vertically. For some of you may already see what the final answer may be. So now 3 plus 0, identity property, that's 3. 2 plus 0, identity property, that's 2. 4 plus 1, I get 5. So my very, very final answer is 505. and 23. I'm so glad we ended up with a whole number here in the end. I'm going to box my answer. And now give me a brief moment and I'm going to write down our very long beginning expression so I can show you how to plug it into Desmos. Okay, I just got that all jotted down, so let's go back to Desmos over here. I'm just going to click enter. Something I like about Desmos too is you can actually see, it'll be an improper fraction and we'll go over how to convert these, but you can see fractions too. I like the decimal answers though. So let's take a look at this. I have -4. And on Desmos, I don't believe they have square brackets. Oh, they do have square brackets. You have to go to the keyboard for that part though. So now I can do 3 in my parenthesis and 9 squared divided by, so see how it's going to do a fraction there, divided by 2. I close my parenthesis, subtract 30, multiply 7. I can close my square bracket now, add 21, multiply 4, subtract 15, and add 10 squared. Why is it giving me a function error? Cannot index. Oh, okay, I see. So they probably are only using the square brackets for something called a matrix. We are not going to get into matrices. So I'm actually just going to replace this with a parenthesis. There we go. And look, we got 523 for our answer right here. And let's double check ourselves. If it loads. We got 523 for our answer here. So you have to be very diligent when you're typing things into Desmos because let's say again, maybe I wanted to add 4 here, 475. But if I messed up and I did my division, which turned into a fraction, and I added my 4 down here, 847 is very different from 475. So notice just how we need to be very clear about how we are typing things into this website, into our calculators, to make sure we're getting the proper answer. But with that being said, that is all I'm going to do as far as order of operations. We got some good review in with adding, subtracting numbers, multiplying and dividing numbers. Please let me know if you have any questions about this. Please review the notes that I have under the lesson 1 folder. Check out the textbook. They have some really good examples in the chapter. And yeah, shoot me an email if you need anything. Let me go back over here. I'll write my email for you guys to see. So my email is mbailey@PMI, Pima Medical Institute, that's what that stands for, that's what we're going to school, right? .edu. mbailey@pmi.edu. Please feel free to shoot me an email if you want to do a tutoring session. We'll figure something out. If you want to call me and have me talk you through a problem really quick, you can call 303 368 7462 and ask for Mars, and they will forward you to my phone, and I can call you from my office, and we can chat through things real quick. It's only if it's a short question, please. If you have a long question, shoot me an email. We'll set up a time to meet. But if you just have like a really quick question, you can make it a phone call, and I can try and explain things to you as clearly as I can over the phone. But yeah, that's it, y'all. Have fun. Good luck with your homework. Let me know if you need anything.